Alright, time to look at our next set of functions, the trig functions. And obviously we've seen trig, but now we want to know how to differentiate, integrate and so on. But before we do, a reminder about the conversion with radians. You might remember last year we did that so we could look in the back of the book and know if our answer was correct, but everything was still in degrees. Well, now in year 12 we need to be able to use radians. The answers will be in radians. It is a better measure to use. Certainly whenever we're using calculus and trig. Whenever we're using calculus and trig, it's radians we want. But first of all, we actually look at this idea of arcs and sectors. There's a circle, and of course we know its circumference is 2 pi r, and its area is pi r squared. But if we don't want to know the whole circle, just a piece of it, so I've drawn a sector in there, and I just want to know the length of the arc AB. Now of course there's two arcs AB there. There's the minor one and the major one. We always assume they're talking about the minor one, unless they specify, major arc. So I know it'll be a proportion of the whole circle, and that proportion will be the angle at the centre. And I guess that's the advantage of using radians, because of the conversion with the 2 pi radians. I can say, well, I know the whole circle is 2 pi radians. So it'll be theta over 2 pi, but the formula for circumference conveniently has 2 pi r, so the 2 pi's cancel and you get a really neat little formula, just the radius times the angle size. But that angle size has to be in radians, of course, for the formula to work. So length of an arc, just simply radius times the angle. And we can do a similar thing to find the area of that sector. The ratio, again, theta on 2 pi. The pi's will cancel, and again we can get a nice neat little formula, half r squared theta for the area of the sector. So, now I've purposely put degrees in there to highlight they give us degrees. In order to use this formula, we're going to have to change it to radians. So length r theta will be 5, not times 45, but 5 times pi on 4. So 5 pi on 4 is our exact value. We want to work out what it is, then of course we substitute in our approximation for pi, 3.1415, depending on how accurate we want the approximation. Area, same sort of deal. Half 5 squared, pi on 4, we end up with 25 pi on 8. Another interesting question they sometimes ask is not to find the area of the sector, but just the segments. So just that little bit in there. Some people like to remember a formula for it. Some people just do it by logic, because we know the area of the sector, but we could just take away the area of the triangle using our half AB sine theta formula. But in this case, A and B are both radius. So you'll notice in both terms we have half r squared theta. So that's the formula some people remember for it. Half r squared theta minus sine theta. But others just, as I say, do it logically. Work out the sector, work out the triangle and subtract. And when we do that, look at that beautiful expression for an area. It's 25 pi root 2 minus 100 all over 8 root 2 centimetres squared. Okay, there we go. That's all we'll do for today. So 14b.